Okay guys, so today we're going to talk about DeMoivre's theorem, which is a way to expand complex numbers, meaning numbers that include I, without actually multiplying or dividing them. So let's just, as a recap, so I in a series of powers equals I squared equals -1, I cubed equals -I, and I to the fourth equals 1. Now that really doesn't matter here, but it's still good to know that anyway. So first off, you're going to multiply. So 1 plus I 3 times the quantity of 2 plus 2I 3. And the theorem that we're going to use here is the theorem of row 1, row 2 times the cosine of angle 1 plus angle 2 plus I times the sine of angle 1 plus angle 2. Bracket, bracket. And so let's talk about these r's first. So if you say that z1 equals 1 plus I root 3, so that we're taking this from this part here. So if you were to plot that on the real versus imaginary numbers line, then you would get 1 here, and then root 3 on the side. Because if this were to go like this, then you'd have the x-axis, and then you would have the y-axis, technically. So, and then you're going to want to find out like which angle it makes. So you're going to draw in your row, which will be r, and you know that from special triangles that r will end up being 2 from your 30, 60, 90 triangle, and from that you also know that the angle for z1 will end up being 60 right here. And then over to z2, which will be 2 plus 2I root 3. Same concept over here, plotted on your axes. 2 root 3, same concept over here, so you're going to, this is going to be a 4 here. And then your angle will once again be a 60 because it's proportional. So here we have R1, R2, and then angle 1, and then angle 2. And now we'll actually use the equation. So now from now on, you're just going to fill in what you already know. So we know that R1 is 2. We know that R2 is 4, bracket, times the cosine of the added angles, which would end up being 120, plus I times the sine, why are there two i's there? Okay, of also 120 because you just added the angles. Obviously that's going to be 8 times whatever the cosine of 120 is, and that's going to be -1/2 plus I times the sine of 120, which is going to be root 3 over 2. And so you're just going to multiply everything out, so these all cancel out, you get left with 4, so -4 plus 4I root 3 is your final answer. And you can always check that with a calculator, but this is one way to do it. Now there are other parts of DeMoivre's theorem as well, and this is another one of them, to take your complex numbers and then put them to a power. So we'll try that with just a simple 1 plus I, let's go to the 10th. And so we can establish that z is 1 plus I, and then you need to know the angle, so and the row and the angle. So we're going to plot this again. You have 1 here, I here, root 2 here because of special triangles. Whoa. And then you also know that this is a 45-degree angle. So you know that theta equals 45 degrees and that your rho is equal to root 2. So let's plug this in. I guess we can use this arrow. So 1 plus I to the 10th equals root 2 to the 10th times the cosine. And then n is 10. And then your theta is 45, so cosine of 450 plus I sine 450. So you'd write that as 32 quantity. Okay, so cosine of 450 is larger than 360, obviously, so let's go over to our unit circle here. We know that a full circle is 360 degrees, and we know that 450 is 90 degrees larger than 360, so you're just going to go up another 90 degrees, and so this is what you would go off of. So then the cosine of 450 is 0, and then the sine of 450 is 1, so it's just going to be 32 times 0 plus I, which is just 32I. Although in standard form, sometimes they're just going to want the 0 plus 32I, but that's usually just for math team, so don't worry about that. Okay, so next we are going to divide complex numbers. So we already know that 1 plus I root 3 would be your z1, and that negative 2 minus 2I root 3 will be your z2. Let's plot these. Here's 1, here is root 3, then your row 1 will end up being a 2, and then your angle will end up being a 60. This is for z1. Now z2 is different because you're in the third quadrant, so you're going to go plot negative 2 root 3. Row is 4, and then the angle all the way over here is going to end up being a 240. I'll mark those. Okay, so now you have all your info. So we'll bring it over here. So R1 over R2 is going to be 2 over 4 bracket cosine of 60 minus 240, which is a negative 180, plus I times the sine of negative 180. This should be a minus here. And so now we will clean it up. So obviously 2 over 4 becomes 1/2. And then the cosine of negative 180. So if you think of it on the unit circle, 180, negative 180 would just be backwards 180, which is technically still 180. And the cosine we know 180 is negative 1. So we will go negative 1. And then the sine, still over here, of negative 180 is 0. So plus 0I. Multiply that out, you get negative 1/2, still plus 0I. Now, the 0I isn't necessary in most cases, but once again, for math team people, or if you just want to be, correct about everything, then go ahead and put the 0I, but it's not necessary. So we'll just leave it as this for now. Okay, so now we're going to find the roots of a complex number. So we're going to start out with finding the 6 roots of 64I. So let's draw this on the coordinate plane. So there's no real number here, so we're just going to go up 64, which means that the angle here will be 90, and then your row will be 64. For now, just don't pay attention to the k. We're going to get there. So r is 64 to the 1 over n, which is to the 1/6. Times the cosine of 90 plus 360k over 6 plus I times the sine of the same thing, which is 90 plus 360k over 6. And we'll just clean it up from here. So 64 to the 1/6 is 2. Bracket to the cosine of, 90 and 360 are both divisible by 6, so that's going to turn into the cosine of 15 plus 60k plus I sine of 15 plus 60k. So now we have something to use for a base. So let's just make sure that we have this all nice and tidy, and then we can go and look at the k's. So you want to find 6 roots of 64i, which means that we're going to take 6 values of k and we're going to plug it in for k and see what we get. Now you can choose whatever you want to for k, but to make it easy, let's just go 0 through 5. So how about we do k equals 0. So that would be 2 bracket cosine 15 plus 60k plus 60 times 0 is just cosine of 15 plus I sine 15. Now it gets a little tricky here because, cosine of 15 is not really like a standard value on the unit circle, but you can find that by making the cosine of 15 equal to the cosine of 45 minus 30. And if you memorize that value, you would know that it's 2 times root 6 plus root 2 over 4 plus I times root 6 minus root 2 over 4. And then to clean it up, that we're going to divide through by, or multiply through by a 2. This becomes a 2, this becomes a 2, so then we end up getting root 6 plus root 2 all over 2 plus I times root 6 minus root 2 all over 2. Now you can write this in a variety of different ways, but this is the best way to show how the I is split up. Now the important thing to remember is that you're going to need 6 of these little things here. So I would recommend going k equals 1, k equals 2, all the way down the line to k equals 5. And I'm not going to show them all here because it's pretty repetitive, but what you will see is that you're eventually going to get cosine of 75 and then the sine of 75. Except for it's just the values for cosine of 15 and sine of 15 switched, so the cosine of 75 is just going to be root 6 minus root 2 over 4, and then the sine of 75 will be root 6 plus 2. That should be a plus. No, it shouldn't. Yes, it should. Okay, so these will be your values here. And I'm not going to go over it because it's very repetitive, so if you can just figure out k equals 1, k equals 2, all the way through k equals 5, then you'll get 6 values for what the power should be, for what the root should be. Okay, so this is where it gets really, really crazy. So here is one isolated problem here. So we'll just worry about this for now. And so obviously you don't want to multiply that all out. So there is a formula for this that Glennon has figured out that basically multiplies the rows, each row times its times the power that's given, multiplied by the cosine of the power times the angle, and then add the first 2 and then subtract the second 2 and then do the same thing for the sine. So we're going to do this for this. So let's find our rows and angles first. So 1 for this first one, root 3, row is 2, angle is 60. Second one, 2 root 3, row is 4, angle is 300. For the third one, you have going down to -3, -3 root 3, row is 6, angle is 240. The fourth one, -4, 4 root 3, row is 8, and the angle is 120. So we can put this into a nice little chart. So we'll go Z1, Z2, Z3, Z4, N, theta, row, actual rows this time. And then N is just the power, so that'll be a 4, 6, 12, 8, 60, 300, 240, 120, and then the row will be a 2, 4, 6, and an 8. Okay, so now we can actually plug stuff in, and I'm not going to write out the whole thing. It has to do like within the cosine and the sine here because that's way too much, and you can just go back to the previous slide. Okay, so P1 to the row 1 to the n power, so that will end up being 2 to the 4th times 4 to the 6th over 6 to the 12th and 8 to the 8th bracket cosine. And you are multiplying the n and the thetas. Cosine of 4 times 60. Let's go to bracket here. Plus 6 times 300 minus 12 times 240 minus 8 times 120 bracket plus I sine of the same thing. Like you don't have to write it back out. That's kind of a lot of writing, so then just calculate it from there. So eventually, after some figuring, you are going to get 1, wait, where's the thing? Okay, 1 over 5, 7, 2, 5, 6, 2, 7, 8, 0, 1, 6, which kind of sucks, but hang on a second. So cosine of all of this dandy stuff is actually going to give you cosine of negative 1800 plus the plus I times the sine of negative 1800. And then it turns out that the cosine of negative 1800 is 1, which means that the sine of negative 1800 is 0. So this is gone. If this is 1, then all you really have to do is multiply 1 by this thing. So that means that your final answer will be 1 over this thing, which if this number is a product of powers, then just write it like in factored form. And then that just ends up being 1 over 2 to the 20th times 3 to the 12th. So not a very fun number to actually write out. El final, everyone. Good luck on that test.